Looking at one like number 3, 3 is a little different. It tells you that J right here is the midpoint of KM. So we automatically know that those are going to be the same because the definition of midpoint. If it's the midpoint of NL, we also know those are going to be the same. They don't want me to prove anything about two triangles here though. But I may have to use that because what they want me to prove is actually that this KL is the same as NM. Well, how do I do that? In order to do that, I need something about angles because I remember that in order to prove things are parallel, I'm going to have to do a converse here. So it's going to have to be something about an angle. What would be nice is if these two triangles, this one right here, JKL, was the same as MJN, these two. We're close to it. We got two sides. I just need an angle or a side. I'm going to jump to an angle here and say, well, aren't these two automatically congruent? Because these two are vertical angles. And we can prove that they're congruent, in which case I'm going to get side, angle, side. So in other words, you're going to get here the triangle JKL is going to be congruent to MJN. Why? You're going to get because of side, angle, side. That's going to be your reason. But once these are congruent, then and only then, I know every part of these two triangles are going to be the same, including the side, including these angles. Well, wait a minute, the angles are really nice because then I know these two are going to be the same. I'm going to call that LKM. Okay, or you can call it MKL, either one. And the other one I can call KMN or NMK. But I know that these two angles will be the same. Why is that useful? Because then I have alternate interior. And if the alternate interior angles are the same, then these lines have to be parallel. And that's kind of my thought process as I walk through this proof.